Hey everyone, welcome to this video. So this is just going to be a video lesson going through the topic of arc length. So far we've talked a lot about arc and angle measures, and measures are what you're familiar with working with. So things like, oh, this measures 60 degrees, or, it measures pi over 3 radians. They're ways of describing how much of a circle is taken up, right? So if I'm looking at something that measures, say, 85 degrees. That's what this looks like approximately to me. If this angle or this arc is 85 degrees, that means that it takes up 85 3/60ths of the circle, right? Or if something is pi over 4 radians, it's taking up a quarter of a semicircle, right? Or an eighth of a circle. It's about how much of the circle is being taken up. An arc length is the actual length or size of an arc. So for instance, this arc is 4 inches long, or this arc is 10 inches long. And it's kind of interesting to measure something that's curved in terms of inches or centimeters. It would be something that you couldn't necessarily measure with a ruler, but everything does have a length. So basically, if I could take this part of an arc, right, here's the rest of the circle. If I could take this part of the arc and straighten it out and measure how many inches it was, that's the arc length. And so that's what we're going to be focused on today. And just before we even get started, just a little FYI, arc length is represented with the variable s. Okay, so that might not be super familiar to you yet, but just bear that in mind as we move through this. So as we get to our first problem, I'm showing you a circle with a central angle that is measured in radians. We know that the intercepted arc would also be pi over 3 radians, since a central angle and its intercepted arc have the same measure. But I want to know s, which again is the arc length. So actually, how long is this? And in order to do that, I will use both the measure of the central angle as well as the length of the radius. So when we learned about radians, we learned that a radian is just the number of radius lengths around the circle that have been taken up, right? So if I took this radius of 3, okay, and I put that 3 around the outside of the circle, right, wherever that 3, whatever it is, 3, let's just give it a unit to make this easier. Wherever that 3 centimeters ended, the angle to that location would be 1 radian. Okay, so again, a radian is the number of radius around the circle. So let's say I want to know the length of this arc S. It's actually easiest to do when this measure is in radians, because if the radians is just the number of radiuses around the circle, I can take the radian measure, and if I multiply it by the radius, I have my arc length. Okay, right? So I'm going to say that again. Okay. Since a radian is the number of radiuses, right? So I'm giving you the number of radiuses already. Well, if you just multiply by the radius, right, because it's the number of radiuses times the radius length, that's going to give you the arc length. So essentially, my formula here is that arc length equals the radius times the measure in radians. We use theta as a measure of angles in this case. That's going to be the measure in radians. So I basically multiply the number of radians times the radius length. So if I want to know what s is, that's just going to equal pi over 3 times 3. Okay. And if you were to multiply that out, the 3's cancel. Okay. The arc length is pi centimeters in this case. Okay. Right. So again, this is the formula we'll use when something is in radians. Okay. So keeping that in mind, right, arc length equals radians times radius. Okay, now I'm going to give you a measure in degrees. Now in degrees, this doesn't work the same way because a degree isn't the number of radius lengths in a circle. So the degree does not directly relate back to the radius length. So we have to approach this in a different way. There's two ways we can do this. One, I can look at the arc length as a fraction of the circumference, right? It's basically just a part of around the circle. And I could have done this for the last problem as well. But I could do that, or I could basically just convert this angle measure into radians and solve it that way. So first we're going to do this as a fraction of the circumference. So if I have a 60-degree angle, okay, right, a whole circle is 360 degrees. If you were to simplify that fraction, you get a sixth of the circle. Okay, so if I can find the whole circumference and divide it by 6, or multiply it by a sixth, then I have the arc length. So circumference equals 2 pi r. So since the radius here is 12, 2 times pi times 12, the circumference is 24 pi. And if I take a sixth of 24 pi, I get the arc length, okay? And a sixth of 24 is just 4. So my arc length would be 4 pi units. Again, there's not units here. Let's say that's in inches, then this would be in inches. Okay. But now I want to talk about it in terms of this formula over here, right? So how can I plug in that angle measure? Again, the 60 degrees itself can't be plugged directly into that formula because that formula is for radian measures, right? That's for radians only. But if I go in here and I basically just for theta, I plug in 60 times the conversion factor, then it could work out that way as well, right? So instead of just putting in the measure, I'm putting in 60 degrees, okay? And then if I were to convert degrees to radians, I would have to multiply by pi over 180, right? So I'm just going to do that right here in this calculation. So now that gives me a conversion into radians so that I can just multiply this by the radius, which is 12. Okay. And if you take 60 over 180, that would simplify to a third. So I'm going to switch this to pi over 3 times 12. And if you do 12 over 3, that's 4. So you'll see that this comes out as 4 pi inches, just like the other method. Okay, so both of these are ways that we could find the arc length. What I want you guys to do is I want you to pause this video and see if you can solve for what the arc length in this circle would be, and then I'll go over it once you rejoin. Okay, so what I'm going to do is I'm going to go ahead and I'm going to use this formula, radians times radius. But again, this theta needs to be converted. So if you are going to convert that, you're basically going to have to take the measure. The measure in degrees times pi over 180, because that's going to be my conversion, okay? And then multiply by the radius. So I can take the arc length times 100, the arc length equals 100, because that's the measure in degrees, times pi over 180, times the radius, which again happens to be 12 in this case. Okay. And if I go to do that, right, you could use a calculator to try to simplify this out to make it easier on yourself, but I see that both of these end in 0, so I'm just going to cancel that part. And then I know that 12 over 18 would be 2/3 because they're both divisible by 6, so I'm going to make that a 2 and this a 3. Those were gone, right? And so it becomes 10 times 2, which is 20 pi over 3. Okay. And again, if you had wanted to do 100 times 12 first and then try to divide by 180, you could. It's just if you simplify the fractions before you multiply, then you have much smaller and easier numbers to work with. Okay, and so that would be the arc length here. Awesome. So now that we have gone through those, what I want you guys to do is in your packet, flip to page 3, and we're just going to record down the formulas that you can use for arc length. Okay. And I'm actually going to start with given radians because that one's the simpler formula, right? And I always remember this. I just say arc length equals radius times radians. Okay. So you could say equals r times theta, radius times radians. Oftentimes you'll see the theta written first. It's multiplication, so it doesn't really matter. I say radius times radians usually when I'm trying to remember this. So you could put the r first. If you prefer, you could write theta times r, radians times radius, but either of those would work. And then if you want to put this in degrees, remember we're just doing the same exact thing. I'm taking basically theta times r, but I want to convert theta into radians. So if theta is given in degrees, right, we would still use theta because it's still an arc length. So if theta is given in degrees, then you need to multiply by pi over 180 in order to convert it into radians. And then you can multiply it by r. And you could put that times r off to the side, or you could put it in the numerator as well, right? Sometimes it'll be easier to do the calculation if you just see it in the numerator. So theta pi r over 180. And again, if you're trying to remember that formula, it's just radius times radians, but you're converting into degrees. Now, these are the two formulas that you can use to find the arc length in any problem. If you have a problem where you're, say, given arc length, you can also use these formulas, right? You would just plug in arc length where it goes, and you'd be able to solve for either the radius or the angle measure or arc measure. So now that we have a little more formal notes on this, we're going to do a little bit more practice. So again, I want you to pause this video. You can record this either on a separate sheet of paper, or if you look in page 7 on your packet, if you want to get some extra examples in your packet, that's just a blank page. So you could record this there, but I want you to go ahead and solve for the arc length here. Pause the video, and then I'll go over it when you come back. Okay, so in this example, you are given a measure in radians. So I'm just going to do radius times radians. Pretty simple calculation. My radius is 5 feet. I have 1.8 radians. So all I have to do is multiply 5 times 1.8. Okay, and if you do that, you would get 9. So the arc length would just be 9 feet. S equals 9 feet. And yeah, that's basically all there is to that. Okay, another example. This one is given in degrees. Again, go ahead and pause this video, solve, and then come back. Okay, so going over this, since we're working in degrees, I am going to use the degree formula. So angle measure times radius times pi over 180. Okay, and so when I go to plug in, the angle measure is 135 degrees. The radius is 8. Have that pi and then divide by 180. Again, you could use your calculator to multiply out here, but if you aren't using a calculator, you would definitely want to go ahead and simplify the fraction first before you multiply by 8. Okay, so 135 over 180 is 3/4. Hopefully you recognize 135 is 3/4 of a semicircle. That's how I know that so quickly. So if we have 3 times 8 pi over 4, right? And then you can see you have the 8 over 4, so I could cancel that to make it 2, and I have 3 times 2, so 6 pi. Okay, again, that is the same thing that you would get if you had just done 135 times 8 over 180 in your calculator, but whenever you don't have your calculator, you do want to start by simplifying first. So hopefully we're feeling a little more solid on those. Now we're going to go through a few more practice examples that are in your packet. So this is on page 10 in your packet. I think you should be able to do most of these. So again, if you could go ahead and pause, try these on your own, and then you can come back and we will review them together. Okay, so the first thing I'm going to do is label the given information as always. So circle C, so I know that C is the center, has a radius measuring 2 inches, and it's telling you that AE and BF are diameters, so you know that those are going straight across to just help us when we're finding angle measures and everything. So I'm just going to label one of my radii as 2 inches to help remind me of the radius length. When I go to find the circumference, remember circumference is 2 pi r. And so I just have to plug in that radius of 2. So 2 pi times 2 would give me 4 pi inches. And then you're given the measure of angle ACB as 90 degrees and asked to find the arc length. I could plug in to the formula for arc length here. This is one of those cases where it probably makes more sense to just consider this as a fraction of the semicircle, 90 degrees, right? What fraction of a circle is that? Right? That's a quarter of the circle. So that arc length is a quarter of the circumference. So if the circumference is 4 pi, right? You take that, you divide by 4, and the length is just going to be pi inches. Okay. Again, you could plug in if you had done theta, so 90 times the radius times pi over 180. You can see how this would have come out as the same thing, right? 90 times 2 is 180, and that over 180 would have canceled to leave you with just pi. So either way, you get the same thing. Okay. Next, I'm given the measure of angle DCE. So let me find that. DCE is pi over 4 radians. Okay. What is the length of DE? Again, I can think of this as a fraction of the circle, or I could think about this using the formula. The formula is so simple. With radians, you almost might as well just do that. Again, personal preference, but just radius times radians. So if I go to plug in there, the radius is 2. Okay, radians is pi over 4. Okay, so you end up with 2 pi over 4, and 2 over 4 simplifies to a half. So you just end up with pi over 2 inches. And then we asked for the length of DAF. So arc DAF, that's going the whole way from here to here. Okay. Again, a couple ways you could think about this. You can use fraction of the circle. You can plug in, right? I can tell that if this right here was pi over 4, then this right here also has to be pi over 4, right? Since they're making up an, 90-degree angle there. So I'm looking at basically 5 pi over 4, right, as this arc measure, because I have the pi from the semicircle and another fourth. So radius times radians, right, 2 times 5 pi over 4, okay, ends up giving you 10 pi over 4, which would simplify to 5 pi over 2. Okay. And then this last one, the bisector of angle DCB passes through the circle at point Z. What is the length of ZF? So I'm going to have to draw in this bisector. So I'm going to actually erase this to clear up my diagram a little bit. Okay. Bisect, what's that mean? You want to cut something in half. So I'm bisecting DCB. So cut in half would look approximately like that, and it intersects the circle at point Z. And then I want to know the length of ZF. So that arc right there. Right? Interesting. So I need to figure out what the measure of that arc would be. Well, if I look at, I knew that this was pi over 4, right? And so I knew that this whole thing was pi over 4. So if I just want the part that gets me to Z right there, that's going to be half of pi over 4. Or in other words, pi over 8. Okay. So when I go to try to find that arc measure, I know I'm going to be working in eighths because that's my smallest unit. So this right here, okay, this right here, that's 1/8. We've got a quarter, that's 2/8. Over here, we've got pi over 2. So I'm thinking about how many eighths that is. It's bad too, right? But so that's going to be a half would be the same as 4/8. So I have 4/8 here, plus 2 here is 6, plus another one here is 7. So I'm working with 7 pi over 8 radians. Okay, and so if I just multiply that by the radius, then that would give me 14 pi over 8, okay, which would simplify to 7 pi over 4 inches. Okay. And again, if you wanted to simplify this 2 over 8 here, you could have. When it's small numbers, sometimes I just multiply it out and then simplify because it's not super hard to work with numbers like 14 and 8. But again, you can simplify first if you prefer. Okay. So we're going to go on to a few more examples. We're not going to do all of them because this is getting a little long. These 7 and 8 are just finding arc lengths. We're going to skip to 9 because that's one that uses an arc length to find some other information. So you have an angle given in degrees and an arc length. So I'm going to plug into the formula for arc length in degrees. Okay. Alternatively, you could just convert that to radians first and use the radian formula. That honestly might be how I would do it, but I'm guessing most of you would rather do it the other way. So I'm just going to plug into this formula right here, right? S equals theta r pi over 180. Okay. And then I'm going to go ahead and solve for what I don't know yet. So you already know the arc length is 40 pi centimeters. That was given to me. Theta, the angle measure, is 225 degrees. I don't know the radius. So the radius is what I'm going to solve for, and I'll use that to find diameter. Okay, so I have this right now. 40 pi equals 225 r pi over 180. Now, I want to get r by itself, so I'm going to get rid of a bunch of these other numbers. Honestly, again, it's really going to benefit you if you can simplify that fraction first. So you want to simplify 225 over 180. Okay. Again, if you can think about these in terms of like portion of a circle that 225 would be, this could help you out. That would simplify to 5/4. Okay. If you need to like divide them both by 5 and then like kind of work your way from there, that's okay. But you just need to make sure you fully simplify that fraction either way. So since I don't have a lot of space to work here, I'm just going to erase that and make it 5/4. 5/4. And now it's going to be a lot easier to cancel this stuff out and get it away from the r. If you wanted to multiply both sides by 4 first and then just divide, you could, but I'm going to try to simplify my work here and just multiply by the reciprocal. So basically cancel everything out in 1. So I'm going to multiply by a fraction since 4 is in the denominator. If I put that in the numerator, I know that those will cancel. And then I want to get rid of the 5 and the pi in the numerator. So I'm going to put a 5 pi in the denominator, because then 5s will cancel and the pi's will cancel. I just need to multiply by the same thing on the other side, so 4 over 5 pi here as well. Okay, and when you do this, you'll notice those pi's will cancel, right? You have pi divided by pi. And then again, you could do 4 times 40 first and then divide by 5, but I'm going to simplify, at least in my head. I know that 40 over 5 is 8, so I'm just going to be doing 4 times 8 here. Okay, so my radius would be 32 centimeters. Right? And again, I was doing that by just saying cancel this out and make it an 8. Okay. So 4 times 8 equals 32. Now, I have to be careful. I was asked for the diameter, not the radius. So then I'm going to just take this and multiply it by 2 so that I answer the question at hand. So that is how we would find this in a problem given degrees. In the next problem, an arc measuring a 9 pi over 4 inches lies on a circle with a radius of 3 inches. Determine the measure in radians. So I'm going to use my radian formula here, which is going to make my life a little easier. Arc length equals radians times radius. Okay, so I'm looking for the measure of the angle. So I'm looking for theta. I was given the arc length. You can tell because this was measured in inches. It says an arc measuring that many inches. Really, an arc with length of that many inches is probably how you would normally see this, right? But again, it is a length if it's given units such as inches or centimeters, right? The measure of the angle would be in degrees or radians. So the length is 9 pi over 4 inches. So I'm going to plug that in on this side, equals the measure of the angle times the radius, and the radius is 3. So here, in order to get the variable by itself, all I have to do is divide by 3. And so I'm just going to put that 3 down here in the denominator of a fraction, right? That's what dividing is, putting in the denominator. And then I have 9 pi over 12, basically. Or if you'd wanted to, you could have taken that 9/3 and divide it out to make it 3. But you can see there how you end up with 3 pi over 4 being your angle measure. Okay. And it's coming down radians. You were asked to leave it in radians. So there we go. Okay. So hopefully you were able to follow along with this. You will have some more practice to go through in class over the next couple days. Everything will have like answer keys or videos to help you go through it. There's also a ton of supplemental resources on the Canvas page, including some videos just by other teachers who went over arc length. So if you feel like you need a little bit more explanation or some different examples that weren't the ones covered here, you can go through those as well. But please make sure that you are following along over the next couple days. Again, you will have a graded assignment that does cover this at the end of class on Friday. So you need to make sure that you're totally solid with this by then. Other than that, you are done your homework and just go to class ready to do some work tomorrow.